Well, I do. Maybe some other do. Yeah. Well, only 3 or 4. Yeah. So it sounds boring. It's almost boring actually. But if it's done well, it can be interesting. So this is actually SSH logs of someone trying to brute force my machine. So I guess a lot of you have seen this already. It's just someone trying some different usernames and then trying to break into the machine. And you know what? That works fairly well because you have so many people who have a guest account on their SSH and they forgot it was on the internet. And there's so many accounts like that. That's just amazing. You can see the scanning, very quickly if you set up an SSH machine on the internet. So how do we detect that? First, let's say that come on, a user enumeration. It will be caught by your intrusion detection system. It's very obvious, right? You have some patterns that are repeated again and again, and you have tools like OSEC that will actually see for this kind of connection appearing and correlate. If we have more than 5 users being tried from the same source IP address in a short time range, it means that it's almost a brute force. The thing is, if you look in your logs, it's not 5 lines, it's about 2,000 lines, 1,000 lines, 5,000 lines, 10,000 lines. It means that you divide that number by 5. That's the number of alerts that you get that are supposed to be correlated. It's way too much. You get way too much information. And you have some ideas that actually have a trigger, but then this trigger is easily off, and again you have a lot of alerts coming in. Other thing about log analyzer tools, their common weakness is that they are signature based, means they are always behind. Because you have a signature of an incident, and then you can automate the detection of this incident. You're always behind. Even though it's still good to have, I'm not against this kind of tool, right? You just have to know that you're always behind with these tools. Another thing about log analysis, your enemy is configurable logs. Do you think you have a lot of software where you can configure logs the way the logs are output? Apache, for example. Squid, for example. So Squid has a configuration parameter, which is log format Squid, and then you have some various options. It's nice, actually. You can put things you want in your logs, but whenever you need to automate this and the detection of evil stuff happening with Squid, it's pretty hard to have something working because you have to deal with regex, and every time someone changes the configuration, then you have to rewrite to regex and things like that. It's never ending. You have some nice options like here. You can log the request method, the URL. You can log anything you want. It's configurable. It sounds nice, but it's not nice for your analysis. ProFTPD has a mod that is called mod log. So you can configure ProFTPD to actually log with those parameters. Again, it's configurable logs. Apache. Interesting thing with Apache is that there is a %p, which means that you will log the response size bytes, excluding the HTTP headers. And there has been some actually vulnerabilities exploiting this, because you can put things you want in the HTTP header, it won't be logged, and that's interesting. So let's find something called, I don't know, I never heard about it, but a log misuse ODE, right? It's something when the application fails to properly log, when there is a log injection possible, so when you can actually, play with your ideas by injecting things you want, or when you have information that are incorrectly logged, let's call that a log misuse ODE, right? Because it can actually be very troublesome on your infrastructure. And something is that there is no log misuse ODE database. There is no common database where we gather information about weakness in logging. So let's find a log misuse ODE today. So back on ProFTPD, remember there is an option in the log format, %a, that will log the anonymous username with a given password. So given passwords actually gets anything. You can put anything you want in the password whenever you are, going on an FTP server. And if you look at the code in ProFTPD managing the password, you can see right here that the pass option is appended to the string that will be right in your log. It means that if instead of your password you write your SSH, what you've seen before, the application will report some SSH attempts being tried. So it's pretty interesting that there is actually nobody talking about this kind of stuff. It has no value on the security market, but it has a real value for attackers. Because it's really something that attackers can use and defeat your intrusion detection system. And I'm telling you that when you are managing more than 1,000 machines, you need to have a reliable logging. If you don't have reliable logging, you have a problem. So remote log injection is possible in varlog ProFTPD auth.log. So actually I said there was no log ODE database. There is one that is called CWE for Common Weakness Enumeration. It's not straightforward, it's not common log weakness or something, but it's fine enough. For example, there is a CWE 778 about insufficient logging, and it's reported that there is an application that doesn't perform good logging, and it's actually a security issue. But I'm sure, who knew about it before? Raise your hand. You knew about CWE? It's not CVE, right? CWE. One person? 2, 3, 4? Less than 10 among all of you. But 10 is a good number. I'm surprised. Last time it was 1 people. Anyway, less than 10 people among all of you heard about CWE, right? And it's actually not very used. It has to be improved. It has to be used. And I don't see much reports talking about CWE. And actually there are some CVE specifying some log issues, so they don't even know that there is CWE for that. So you have, I like the second example, OpenVMS that does not log the source IP. You have things like that. And actually the CVE is here. The one starting in 2003 is still under review. I don't know who is working. Yet another stealth attack in your logs. Have you ever seen this attack in your logs, in your Apache logs? Who's seen it? I guess all of you running Apache server on the web. So too bad the video is recording, but after I can tell you why it's an attack, and that can be pretty interesting for attackers. So another way, actually, of being faster in doing capturing. So it's all about capturing, right? It's network capturing, it's log capturing, it's information we can get from logs and stuff like that. So now let's go a bit further. So I have a laptop right here that has an NVIDIA with 96 CUDA cores with a memory bandwidth of 25 gigabytes per second. It's amazingly fast. I will talk about the CUDA architecture. So the CUDA architecture is made of kernels, and you can define on your kernels how many grids that you want. And in a grid, you can define how many blocks that you want. And in a block, you can define, again, how many threads that you want, right? So a grid shares memory among the different elements. It means that you can send information in parallel to have your information processed by all those threads. And it has no comparison with the CPU from Intel. If you look at the chart, sorry I didn't put it in my slides, but there is a chart of the gigaflop that can be processed by graphic cards and CPUs. The CPUs are really low and graphic cards are like 1,000 times faster. So it's a really interesting way, to go for capturing. If you want to process packets, then send them to the GPU for analysis, and then get the result back. you'd be way faster doing this than using your CPU. So how does CUDA works? First, you have your main memory. The first things you need is that you need to copy your data straight to the GPU memory. The second step is that you instruct the CPU to run something on the GPU. So the CPU will give the code to the GPU so that the GPU can execute it on the different threads. So third step, the parallel instructions are executed on every core, and then you get the result back to the memory, to the main memory. So there is a project that is called NetGPU that can actually capture data straight from your GPU. And this project has the following architecture. Of course, the GPU is only used for analysis. It's simple. A GPU is not a network card. A network card needs a driver to work, and the driver works with a kernel, and the kernel needs to deliver your packet in your GPU, and then your GPU can do the analysis on your packet. Last step, how can we actually manage all those information? As you've seen in the presentation, capture is complex. We need to have rule sets, so we are always behind, and we have too many false positives. We all know that, right? How can we face this? Something I like, maybe some people know about that, is using visualization. I find visualization interesting to handle large data. Here, we have an airport body check. So, all of you have been through, and what happens there, if you have a knife or something, it's going to, beep the gate. And when the gate is warning about the fact that you have a metal or something in your pocket, there's an agent that looks at it, whether it's something threatening the aircraft security or not. If it's just your keys, it's not threatening the security, right? If it's a knife or something, looking at that, then they will find it visually, and you will be blocked, and you will be forced to remove your item before entering there. So the correlation is actually visual from those guys, because we need people to figure out if those guys are threatening or not the aircraft. So there is a community website called SecViz that does a visualization like this, where you have it's called directed drafts. So you have your logs, you process them, you need to have a source and destination, and you combine all of them in this kind of graph, and you get some nice bubbles. But it's one way to describe something happening. Here is a denial of service that is attempted by the different IP addresses that you can see. Another project is called Circos. Circos is actually aligning things around a circle. Do you get it? I don't. Okay, so enough with limitation. Something we have with visualization is when we need to go further than just 3 dimensions. We have nothing left, because a pie chart is